All right, thanks everybody, and welcome to our symposium on implementing a bird and bat tracking research framework with the Regional Wildlife Science Collaborative for Offshore Wind. My name's Pamela Loring with the Fish and Wildlife Service, and I'll be moderating and presenting, joined by my fellow symposium speakers, Nate Fuller from the Fish and Wildlife Service, Autumn-Lynn Harrison from Smithsonian, and Patrick Roberts from the Fish and Wildlife Service. So I'll be kicking us off with a coordinated approach for tracking migratory birds in the U.S. Atlantic. So we're focused on two technologies in this symposium, radio and satellite tags. Both types of technology collect individual-based movement data, but the data vary with the type of technology used. So some variations include the spatial and temporal resolution, the duration that the tags last, and whether or not they have sensors such as barometric pressure sensors, accelerometers, et cetera. And the offshore wind applications vary with the type of data that the tags are collecting and could include, they all include movement, but could also include things like behavioral variation, flight height, and habitat use both in the marine environment and also in the airspace. And the photos on the slide show an example of a really small nanotag transmitter on an Ipswich sparrow all the way up to a large multi-sensor GPS tag on an albatross, and there's kind of everything in between in terms of technology. So coordinated tracking really aims to maximize information gains from tagged individuals across space, time, population, species, and taxa. And coordinated tracking is especially important for offshore wind applications in several different ways. It provides the best available information for assessments. Cost and logistics can limit the scope of individual studies, so it's important to try to leverage across studies where possible. There's hundreds of bird species that use offshore environments, and there's large-scale development happening across the Atlantic, so combining data is really important to address those big questions. So one example of a coordinated tracking study is one that we conducted on shorebird movements in the U.S. Atlantic. We did a collaborative analysis of MODIS data collected between 2014 and 2017. And the shorebirds were tagged across 21 sites from Arctic Canada down through South America. And there were 12 species included, representing over 1,300 individual birds. So from these data, we looked at the routes, timing, and weather associated with offshore flights, and it provided new information on a lot of different species, but it was really limited by the coverage of the MODIS network, which at the time was all coastal stations in our study area. So we've been doing a lot of work with partners to advance the use of MODIS technology offshore. In 2022, with funding from NYSERDA, we released offshore MODIS protocols that are available on the MODIS website and have helped to guide the development of stations on buoys and turbines, including the station on the turbine that you see in the photo on the slide, which is at the CVOW pilot project, with thanks to Dominion for their partnership on that. We have a couple exciting complementary projects to advance MODIS technology. We're partnering with NOAA NESDIS to develop receivers that are optimized for offshore use, including data connectivity with the GO satellite system. So we're really, really excited about that partnership, and it's with their NOAA Joint Ventures program with NASA. So a lot of really smart people thinking about this application. And then we've also been working with Pacific Northwest National Lab on a new project to optimize tags, and this is based off of work that Daniel Deng and colleagues have developed for bat tags on land that we're sort of building off of to use for offshore environments. So this will optimize the coding, specifications, and sensors for our offshore information needs. And the time frame for that project is hoping to have tags to deploy by 2026. So if anybody's interested in testing any species that might occur offshore, definitely feel free to reach out. Satellite tags are getting smaller and lighter, which is really increasing our ability to track shorebirds offshore. So you can see the map shows tracks of red knots flying way offshore, much farther than our MODIS array can detect, and these tags are providing really high-resolution data. The Fish and Wildlife Service is coordinating data from ESA-listed species for use in recovery efforts, and that allows us to bring these big data sets from satellite-tagged red knots, for example, into some of the collision risk modeling that Andrew had just presented about in the last session. So really good opportunities to push that science and information forward. And then the Smithsonian is also doing amazing work to coordinate data across many species and partners for many different types of shorebirds, listed and non-listed. And Autumn-Lynn Harrison will be presenting on that work later on in this session. So a little bit on technologies for terns. In 2017, we did a pilot study tagging 7 adult common terns in Maine with Argos, 2-gram Argos satellite PTTs. These tags collected about 11 points per day, and many of the birds were tracked throughout their full annual cycle, which provided some of the first full annual cycle satellite-based data for terns. Super cool, really small sample size, but there's been some more recent data, full annual cycle, that's been collected with satellite and GPS tags that are being combined in a publication that's led by a grad student, Aaliyah Caldwell at UNH, on kind of the first full annual cycle movement of terns paper that's being published. So that's a really exciting example of how some of these small data sets can contribute to larger analyses that support graduate research and other really cool applications. And you can see just some of the data that we collected from our terns in the pilot study ranging throughout the hemisphere, and then some really fine scale information around the lease areas in the Atlantic as well. More recently, we've been using some of the GPS UHF technology that Don Lyons presented about yesterday in coordination with National Audubon and other partners in the Northwest Atlantic to track common terns. So our portion of the study is funded by BOEM in Massachusetts, and we have tags deployed on 60 adult terns at nesting colonies that are collecting GPS data every 20 minutes, so really fine scale resolution data. The tags are programmed to offload to base stations that are at colonies and staging areas, and we are coordinating this work with Don Lyons and colleagues, including Keenan Yacola, who's doing a bunch of the coordination work through his dissertation at Oregon State, as well as other colonies like Great Gull Island and throughout sort of the Gulf of Maine, Atlantic Canada region. So it's a really cool collaboration. It's been growing, and we're getting tons of really fine-scale data. The map shows data from just 15 of our tag terns collected within about 2 weeks of tagging. So we've got way more to come, and it's just really cool when you combine it all. So in summary, there's lots of opportunities for coordinated tracking, from combining data opportunistically, which is what we've mostly done in the past from data sets that are already collected but complementary, to strategic study planning, which is a topic that Patrick Roberts will address later on in this session. This really is important for providing the best available science for assessments, both in the immediate future to meet our timely information needs for permitting, as well as over the long term for monitoring and just safeguarding data kind of in these centralized repositories. And the technology and information gains are continuing to advance, providing lots more opportunities into the future. And it really fosters a lot of collaboration and complementary uses of the data, such as species recovery, scientific papers, and habitat management. So the take-home message of this talk is that the whole is really greater than the sum of its parts. By combining data across studies, we not only increase our sample size and statistical power for science, but we also bring together the people, places, knowledge, and connections that help us do our work more effectively. So with that, I'd like to thank everybody, and I will turn it over to Nate Fuller to talk about bats.
Okay, so I'm going to more or less rant about how hard it is to work with bats. All these beautiful tracks that you have of birds flying all over the place, and backpacks and different ways that satellite tags work on birds. Awesome. Love it. But with bats, it doesn't work that way. Large bats, it can work that way, but we're not really that interested in large bats in this area. We're interested in these small bats, which are, about like that as the wingspan. If you remember the earlier session, these slides are going to look a little familiar, but offshore wind build-out is definitely advancing in federal waters. We have some very worrying patterns of bat mortality in the land-based systems, and many bats are using coastal and offshore environments to roost, forage, and migrate. The species that we are interested in are not just the ESA bats, the hibernating bats that are affected by white nose syndrome, which are the Myotis species, little brown, evening, and big brown aren't Myotis, sorry. Little brown, northern long-eared, Indiana bat, eastern small-footed tricolor bat. But these migratory tree bats in the second to last row, the hoary bat is currently under ESA discretionary assessment for ESA listing. So it's really important that we find techniques to get more information about how these bats are operating. Agencies are directed by the ESA, Section 7A1, to proactively enact measures to conserve threatened and endangered species. And for birds, you have the ESA and you also have the Migratory Bird Treaty Act, but with bats, there really are no equivalent protections outside of the ESA. If bats are being considered for this stuff, they're basically, it's all or nothing. They have no regulatory protections, or they're going to have full ESA protections. So there are reasons to consider bats in a larger context here. So the goal of what I'm going to talk about here, if you accept that bats are offshore in numbers that warrant conservation measures, which I would hope that you do, understanding movement and phenological data are really critical in assessing risk and exposure. Species-specific flight characteristics, migratory pathing, all these things, this is information that we need to assess. One thing that I've said to lots of people at this meeting so far, bats don't migrate like birds. They don't go from one spot. They don't stop over, fly, stop over, fly, stop over, fly. Bat migration looks like this. It goes all over the place, and it goes kind of in a direction of south, but sometimes they'll jump up here, and then they'll go back down. Because they're mating, they're moving around, they're foraging, they're doing social interactions. It's not the same kind of thing. This is really this is really encouraged or controlled by the fact that bats are heterothermic. So they do what we call torpor-assisted migration. If the weather sucks, they just stop flying, and they'll just park themselves for a week, 8 days, whatever, wait it out, move on. So their energetic landscape is a lot less restrictive than birds. So that makes their migrations more interesting, more convoluted, and also in terms of risk, the cumulative risk is going to grow because they're lingering in an area rather than moving through an area. So how do we get data? Bats are exceedingly difficult and expensive to track, and one of the earliest ways that we would do that is by putting these little aluminum bands on their wrist and seeing if we found them again. In the context of banding studies with bats, a 10% recapture rate is considered excellent. I did a recapture study at a maternity roost in Massachusetts when I was doing my PhD. Our recapture rate was 13%. I was putting nets directly in front of the barn where the bats were flying out. 13% was my excellent recapture rate. There's an old study that I love, this Davis and Hitchcock study. Bats were banded at Aeolus Cave up here in southern Vermont, and then band recoveries were picked up all across New England, and these bats moved some pretty good distance, including going to these coastal environments. The problem is that when you do a banding study like this, they were peeling bats off of the walls, like scraping them off the walls, once a week, I believe, is how it was done, or maybe every 2 weeks, in the middle of hibernation, which, surprise, surprise, the bat population declined after they did that study. So it's very difficult and expensive to track bats because if we use these cheap, accessible models, it actually doesn't work all that well, and it's kind of damaging. In general, this is also driven by the fact that bats are nocturnal. Obviously, they're very difficult to capture enough of your target species. They've got small bodies, which means that the most advanced telemetry tags are inappropriate for use on bats. And of course, there's the 5% rule, where no more than 5% of the body mass of the bat's body mass should be. You shouldn't exceed 5% of the bat's body mass with tag and glue and attachment stuff. So, in the context of bats, you have to. Well, we're going to talk about attachment. You have to glue them on, more or less. Here's a picture of a hoary bat it's sporting a nice backpack tag. This is how you attach a tag to a bat. Attachment really is a problem. You have to glue it to the skin on the back, about right here. And the glue sometimes doesn't work well. You use ostomy cement. You can use veterinary grade cyanoacrylate. The humidity causes lots of problems with the glue curing. The attachments are not always secure. The antenna can interfere with roosting. If a bat is inside a roost and you have this very bristly antenna poking out, the bats may not be able to tuck into places where they go, so you have to be very considerate of that. And sometimes you can get those like floppier antennas, but then a bat can grab it, find it, and chew it off. Happens. It's happened to me many times. And bats are generally just also really good at pulling the tags off. They have loose skin, so they can get behind there, they scratch on it, and they'll just peel those things right off. These hoary bats, hoary bats specifically, are just really efficient at tearing tags off of themselves. There are some ways around this. I just threw up this study real quick. Kevin Castle and company, I think it was Paul Cryan, and I think Gabe Reyes was involved in that one too. They did a study where they've sutured GPS tags onto hoary bats, and somehow managed to get a recapture a year later of a couple of bats, which was really shocking. So that's a cool study to check out if you're interested in. So, and again, here's another question. What do you do about power? How do you power these small tags, and how do you deal with tag longevity issues? This is a red bat with a nice tag on its back. Both the tag size and the longevity are going to be limited by battery technology. Solar charging doesn't work. They're nocturnal. They roost in crevices, so battery life is basically what the battery life is. Although, of course, you look at the CVOW data, and you're seeing that some of these bats are active during the day. So that's cool. But again, if you're trying to glue these things on, you have to encase them in glue, and your solar charging is not going to work there. You can increase the pulse interval to make tags last longer, but you're going to lose resolution on your tracks. And with bats zooming around, with bats zooming around, it's really important to have tight resolution. So power can be a very difficult consideration. You have to really balance these factors. GPS tags can be used with limitations. They are too heavy, pretty much across the board. Oftentimes, you have to recover the data. You have to recover the logger with the data saved on it. And like I said, remember what I said about my recapture rates of 10%? That seems like a very poor investment of firing off 20 tags and getting 2 returns at the end. And long-term attachment is very tough. The suturing thing is one approach. Collars are now becoming something that people are heavily considering. Collars can work, but like backpacks for like the bird backpack things, that's not really an option because bat wings don't look like bird wings. And in my opinion, the MODIS tags are going to be the next best option to GPS, dependent on how your MODIS network looks. You can really get some good data off of that, but of course, all the considerations that go into limitations that go into MODIS. This is a picture of a tricolor bat with a temperature-sensitive tag on it that we got in a culvert in Texas. I'm really happy with that image. But again, those tags were probably a little bit too heavy for those bats, and that's just sort of the limitations that you have to accept. So if you're willing to take risk, you can get some interesting actionable outcomes. This is outcomes. Yes, you can get income after this. So this is a cool study that came out of Europe. It was Christian Voigt and Yossi, whose last name I've forgotten, they're very involved in doing lots of bat tracking work. This is noctule bats that had GPS transmitters attached to them, GPS transmitters that were developed for this study. These triangles here are wind power facilities, individual wind turbines, and they got some really cool GPS tracks of bats zooming around. And with that, you can also make some really cool inferences about what height the bats are flying, how fast they're going, and make cool figures like this, which are actually really, really, really helpful in the context of understanding what your regulatory landscape can look like. Sorry, fruit fly. And I really like this figure because this shows, generally flight height, the median and quartiles of flight height compared to a wind turbine facility in this European study. So if we're willing to take the risk, if we're willing to actually exceed this 5% rule or develop technology, we can get some really cool actionable data out of this stuff. So, the questions I like to throw at people when we talk about bats is where are our needs? Where are the greatest opportunities? Where are our most significant limitations? And how are we going to invest our effort over the near and long term to attack some of these questions? That's it. Thanks.
Thank you, Nate. Next up, we have Autumn-Lynn Harrison to talk about the Shorebird Conservation Collective.
Hi, everyone. I am a research ecologist at the Smithsonian Migratory Bird Center, and I lead a couple of large initiatives that are relevant to implementing a bird tracking research framework. These are both synthesis efforts, but also producing new data, and intended to shorten the path between science and management, and hopefully will provide a strong foundation of knowledge. The Shorebird Science and Conservation Collective, and then I'll end with a little bit of information about the Migratory Connectivity Project. And these are really the co-authors for this talk. About 70 individuals, in addition to myself, comprise the Shorebird Science and Conservation Collective, established over the past 3 years through data contributions and practitioner partnerships. I wanted to thank everyone right away, as well as our funder, the Knobloch Family Foundation, for our initial support. And sorry, Nate, here's a beautiful map of shorebird tracking data. Over the last 20 years, the miniaturization of tracking technology has led to a real boom in shorebird tracking studies, like this one from my group and collaborators on black-bellied plovers. And in a recent review of North American avian tracking studies by Amy Scarpignato, she found that less than 1% of studies in 2006 were from passerines and shorebirds, but by today, 61% of shorebird species have been tracked. And one really interesting thing to mention with shorebirds is that they give us kind of a neat comparison with interior movements that go through onshore turbine wind farms and then also offshore movements. Shorebird researchers really have a long history of working together in a highly collaborative way to execute field projects. We all help each other out, largely in the Arctic region. And given the relatively nascent and growing resource of shorebird tracking data, a group of us put our heads down in the pandemic, as many of us did, and really got thinking about a model for data sharing and translation that could have a large impact on conservation and management even before many of these new studies have been published. And the model that we landed on is to directly support practitioners by not only collating data, but also by providing analytical services using data contributions from across the Western Hemisphere. So the collective acts as an intermediary or a boundary group, not a strict repository, but does link to movement data repositories like MoveBank. We are guided by an advisory group. We have a staff, 2 members right now, a quantitative ecologist and a conservation specialist with me as the PI. And We aim to use data to help reverse shorebird losses by informing land management, species management, outreach, and policy. The proposal for this initiative developed during the pandemic, and we began discussing the idea of collating shorebird tracking data by hosting virtual listening sessions. I think Pam attended one of these with members of the shorebird research and practitioner communities that included representatives from North America, Central, and South America. And these listening sessions really help determine how exactly we would work with scientists to request data, giving a lot of guidance about the way scientists would like to be engaged through the data sharing process. Our first step was to develop a data sharing agreement, which is posted online, that describes that all data contributors retain ownership of the data they share. They are permitted to set use permissions, so contributors can choose to make their data available for any conservation request, or they may request that we ask them permission before each conservation use. And either way, we send a notification of use to every data contributor every time their data are about to be involved in a conservation or management process. And that really helps add to the network of people that are helping us look for misinterpretations of data, really understand the data, and contributors get a benefit of knowing how their data are being used, which is very rare with most open access repositories. When you contribute, you don't often know how your data are being used to try to continue to get funding for the science that we do. So this has been a real benefit to data contributors. We had a really amazing response to this process. 7.1 million shorebird tracking locations have been shared from 75 different organizations across 36 different species. 3,420 tags have been shared, although this just went up by 16, with 16 more Rufa Red Knot just contributed this morning. And something really important to note is that of all of these data, only 18% of the data contributed to the collective are also set as open access in either MoveBank or the USGS tracking data repository, some repository. So most of these data are not actually available to the public yet. Some of them have plans to be. But our process enables these data to be used for decision-making right away, even before they are set to public. The map on the left there shows just species richness of individuals tracked by Argos and GPS. So the hot spots in the interior shows a really neat migration route through the prairie potholes to the Gulf of Mexico with a lot of individuals tracked in this region. And then the coastal areas, it's harder to see because it's a narrower band, but also high species richness of data there. As I mentioned, we send a notification of data use or a request for permission if necessary. About 96% of those requests have been approved so far. We send this to contributors whose data are relevant to the conservation or management use, and then they have this great record. So we give them a map of the exact tracks that are being requested, and it just increases transparency and trust. But how do we work with practitioners? We first reached out when we were getting started through an email campaign to relevant organizations and through word of mouth and our advisory group. We started telling people this data resource was available. When a practitioner gets in touch with us, we first schedule a virtual 1-hour meeting with them where we listen to their information needs, we assess their understanding of shorebird ecology, and just try to kind of co-produce the process where we really want to give them a deliverable that will help them make decisions. After we have that 1-hour listening sessions, we ask them to submit a formal request for data use online. This gives us a lot of background information that we can then give to our notification to data contributors. So this is how we get the exact information that we write in those forms. Since our first data use request in November 2021, the collective has supported 16 conservation projects. We've sent 115 notifications to 24 contributors that their data are being used in conservation and management. And now I'll just provide a few examples of these. First, educators at Grays Harbor National Wildlife Refuge in Washington State requested geographic coordinates and track lines to support their education programs. Educators incorporated data from 17 individuals of 5 species into 4 lessons, allowing students to enhance their skills in geography and seeing how birds in their area are connected to places around the Western Hemisphere. We also make a really nice report at the conclusion of every project just to have a record of the contribution. The Galveston Bay Foundation and Texas Water Trade, 2 Texas-based NGOs, purchased over 5,000 acre-feet of water to actually be able to buy water and put it on the landscape to create shorebird habitat and waterfowl habitat as well. And they wanted to know when and where to deploy water to benefit shorebirds. So we integrated tracking data with relative abundance data from eBird to estimate peaks of migration and wintering occurrence across multiple species. And they actually are using that to understand how long to hold water on the landscape and when to put it on, and they're putting it on soon in August, actually, so that'll be their first deployment. And finally, most relevant to this meeting, and Paul Kanaga mentioned this yesterday, the Canadian Wildlife Service requested information for 2 very rapid regional assessments offshore Nova Scotia and Newfoundland to understand the temporal and spatial distribution of shorebirds moving through their areas. We provided maps of 41 individuals of 8 species, as well as data through the region that they're putting directly into their models. For anyone interested in learning more, this QR code links to a preprint of a paper that fully describes the process. And in a day or two, I'll post a revision. It's in review at Conservation Biology. And that will describe some generalizable lessons learned for others that are interested in stewarding data in this way. And I'll finish in this last minute sharing an exciting new resource that will be available soon, an atlas of migratory connectivity for the birds of North America, about 560 species, from an initiative I manage at Smithsonian, the Migratory Connectivity Project. This book will combine the 100-year history of bird banding data in North America with tracking data, contributions, and insights from genetics and stable isotopes. And the idea is to look at how populations mix and separate over time. So to really get to the population level, as Julie Miller mentioned in her talk from Scotland. And just an example, I'm editing the seabird portion. With seabirds, there is so much information available given the longer history of tracking. So these maps will have kernel density estimates of breeding and wintering areas when available, showing how populations come together or separate. And we've also estimated migratory corridors that won't be in the book. Most of the emphasis is breeding to wintering connections. But all of those data sit on our computers, and I think it'd be nice to have a conversation about how we could best use those data and mobilize them for this process. So they'll be in a book, but how do we make them actually usable? So I'd be happy to talk about that with the panel. And so here's just another short website URL if you're interested in learning more about the collective, and please do email me if you have any questions. Thank you.
Thanks, Autumn-Lynn. That is amazing. Next up, we'll have Patrick Roberts talking about a strategic approach for species prioritization.
Thanks, Pam. Let's see. So as Pam mentioned, today I'm going to be talking about efforts within the Regional Wildlife Science Collaborative to develop a process for prioritizing species for avian tracking research. So myself and Pam at Fish and Wildlife Service are helping coordinate this along with Kate Williams and Evan Adams at BRI. But this is really a collaborative effort. It brings in information from lots of different individuals within RWSC, so it's really very much a group effort. So as you've heard from the last 3 talks, tracking research and tracking technologies are immensely important for understanding how birds and bats use the offshore wind or offshore environment, and also in terms of understanding and assessing vulnerability to offshore wind development. And as of right now, it seems like almost all of the monitoring plans that I know of for individual leased areas are going to incorporate tracking technologies to one degree or another. And one kind of fundamental component of any tracking study is simply deciding what species you're going to focus on. And it's a really critical question, and there are a lot of challenges associated with it. And that's particularly challenging within the offshore wind environment, where there are many, many species that may occur offshore. No one knows exactly how many species are regularly using the offshore wind environment, but it could be on the order of hundreds, potentially 300 plus species. So with the relatively limited resources that we have, it's critical to make sure that we are doing a good job of understanding what are our priority species moving forward in terms of which we identify for tracking research. So that's the impetus for this project. And I'm really going to cut to the chase in terms of how we're thinking about prioritizing species. The central component of this effort is this idea of a ranking metric. So an objective and semi-automated way to assess different species for a given area and essentially spit out a list of species that could be high priorities for tracking research. And this ranking metric is made up of 3 distinct components. The first of which is conservation status, so the vulnerability of that species to extinction. We have vulnerability to collision. And last, we have exposure of that species population within the Atlantic to any given area of interest. Another core component of this, the way we're thinking about prioritization, is the idea of prioritizing within functional or taxonomic groups. So I think the most fundamental way to think about, to kind of break species up in terms of how they interact with the marine environment is thinking about, on the one hand, our marine birds, our species that occupy the marine environment during the breeding or non-breeding periods. And then on the other hand, all of our other species that are essentially using that environment for migratory purposes. These are species that are much less exposed to offshore wind than marine birds, but that exposure, at least at the population level, is potentially much more acute. So it makes sense to think about these species and prioritize them separately. But within this group, we're also thinking about prioritizing at the kind of the taxonomic level, and this is more for kind of logistical purposes. We're currently focusing on shorebirds and passerines, but we're going to be breaking this out into other taxonomic groups, and I'd love to chat with people about how we might do that. So I don't have really any time to give you much of the details of how we're going through this process, but I do want to give you a sense of just a little coarsely kind of what this looks like. So in terms of how we're thinking about conservation status, we're first starting out with the RWSC's more or less comprehensive Atlantic bird list. This is made up of 417 species. Many of those species very likely do not occur offshore, but we're really trying to be as kind of encompassing as possible within this effort. So the first thing we did after bringing that list together was to really think about all of our relevant conservation metrics that kind of assess conservation status. And what we started to kind of realize with this, that they fall out into kind of these core spatial/jurisdictional scales. So in orange here, we have this kind of global continental scale. In green, we have the national scale. In blue, regional. And in yellow, we have kind of the state-level spatial/jurisdictional scale. And so the idea here is that we really want to make sure that we're kind of representing all of the possible perspectives on conservation status that we really can. So we're trying to be as inclusive as possible within this process. So I can't give you many of the details, but we make sure that these are all kind of on the same scale and they're comparable. We combine them into a single score for each scale. And then we combine all of these scales into a kind of a single overarching metric for conservation status. Again, this process is very much in the works, so I expect for this to change. It could revamp this, refine this in many different ways, but this is kind of how we're thinking about it right now. Moving on to collision vulnerability, this is relatively straightforward. We're relying on this immensely kind of fundamental, important document by Wilmot et al., 2013. This is really kind of the core document assessing vulnerability to collision in the Atlantic. So we're using those scores. We acknowledge that these are from 2013, 11 years ago. So we're kind of in the process of talking about what an update to this might look like. So that's going to incorporate that information as we move forward. And lastly, exposure. This is kind of the component that we're really still very much in the process of thinking about how we might incorporate this. On the one hand, we have really amazing data for marine birds. Arliss Winship et al., he gave a talk yesterday about the MDAT layers, these spatial relative abundance layers for the entire Atlantic. This is essentially the best case scenario for marine birds, and this is what we're moving forward with in terms of assessing exposure. But for our other kind of taxonomic groups, shorebirds and passerines and other groups, this is a much more challenging thing. We're probably never going to get to that level of data for those species. So we're trying to think about how we might approach that process, and it's still very much in the works. We're thinking about potentially using coastal banding data as a relative measure of exposure to the marine environment, those species that are more likely to jump off from those islands and coastal banding stations. But we're also thinking about other tools like the Audubon Migration Explorer, eBird, also the injury mortality reporting database that Fish and Wildlife collects, and we'll be getting more data from the offshore projects as they move along. So that's kind of how we're thinking about this. Kind of giving you a little bit more detail into exposure specifically, we're defining this exposure as the proportion of the predicted Atlantic population within any given area. Arliss kind of described this in his talk yesterday, and I'm not going to go into much more detail than that. But that is kind of that's the kind of the core of this idea. And as we're developing this metric, we're making sure that we're thinking about different spatial scales. So we're kind of operating right now. We've chosen to operate at kind of the lease and planning level scale, but also at larger spatial scales, like the RWSC subregions as well. So we're thinking about how this process kind of plays out when you're kind of operating and thinking about generating lists at different scales. So the next step is to bring these components together. And since we only have, we're only doing this for marine birds at the moment because that's what the only group that we have exposure data for. We're approaching this currently through kind of a weighted mean approach where we apply essentially like kind of expert-derived weights to these different components and seeing how that plays out. And that's still very much in the works and needs to have a much more expert-influenced component there, I think. And the purpose of this talk is really not to kind of give you lists and to have you see whether you agree with them or not, but I just wanted to kind of throw these up there and give you a sense of kind of what they've looked like right now. These are really preliminary, and they're very likely not going to look like this. But on the left here, we have our New York bite, New Jersey bite list for marine birds. We play around with a lot of different weights, so we have a lot of different lists. This is just one of them. On the right, we have that kind of initial WIA that was developed in the Gulf of Maine. That's kind of where it was at when we were developing this process. So that's what it's looking like right now. But again, I mentioned that this is really only the core kind of component of this process. We're also implementing other ideas into this process. So we're thinking about existing data. Some species are really well studied. Maybe certain species we could just take and put aside and move forward with the rest of the species. We're also thinking about feasibility. BRI has thought a lot about this. This is kind of one of their core ideas that they brought to the table that I think is fantastic and is centered around kind of the idea of the fact that certain species are just more challenging. Certain species are just potentially unrealistic in terms of studying. So maybe we can, through expert opinion and through other methods, assess that and allow that to contribute to this list as well in some kind of quantitative way. Certain information is just not realistically quantifiable. We can't insert this into this ranking metric easily. So that's where expert opinion can also come in other ways. And lastly, human dimensions. In particular, we're interested in incorporating tribal priorities, but there are also stakeholders that might have specific species of interest, and there might be ways to incorporate those species into this process. So last, in terms of next steps, I think this is really kind of the core of this is we want to be as collaborative and as inclusive as possible. So we want to continue to do that. And so I'm really interested, if anybody's interested in participating in this process, we would love to have your involvement in the Bird and Bat Subcommittee group, or even more involvement if you're interested. But we do, this is, again, I'm just reporting on kind of where we're at in this process. So we want to continue to refine that. We've got a long list of things we want to do. We want to incorporate those other components that I just mentioned. And last, we want to really dive into implementation as soon as we kind of get to a place that we feel comfortable with. That can look like a lot of different things. But one thing we're thinking about right now is, particularly for marine birds, there's the potential of developing some kind of really flexible, user-defined decision support tool for marine birds, where essentially you're kind of delineating an area and it generates a list through these criteria for you. So that's where I'm at. Thank you.
Thanks so much, Patrick. And I'd like to invite all the speakers up. We'll have our panel until 5 o'clock, so please put your questions in the app, and we'll try to get to as many as we can. All right. Oh, I think we all need to turn. I did. We did. Perfect. So I'm kind of new to the app thing, so I'm just going to answer them in order. So have any appetite for shipping freighters to have MODIS receivers on them? So we have done some MODIS boats, and it's really patchy in terms of coverage because it's like a moving platform and you have limited detection range, and oftentimes boats have lots of other VHF interference on them. So we kind of tried the boat thing and passed on it moving forward. But if folks have creative ideas on ways to make it work, always happy to chat. Let's see. All right, here's one for Autumn-Lynn. How are pretty different data types of tracking data, such as MODIS, GPS, and satellite, used in data analysis requests like the offshore wind shorebird assessment?
It's a really great question. About 2,000 tracks contributed to the collective or Argos GPS, and we really prioritized harmonizing and processing those data first, because we did anticipate that they would be most relevant to most of the requests we would receive from practitioners. And so the way that we determine that first is from the practitioner needs and from those conversations that we have in co-developing the process. If we think that MODIS data just may not have suitable temporal frequency to answer the question, then they don't, and so we use what does. So it's really driven by the questions that practitioners need to answer. We have had some cases, especially about connectivity, when all data sets are relevant, so how are populations connected? And in those ways, we use modeling approaches to bring together uncertainties around those different error types. Maybe we have to interpolate across less frequent time sampling, and so there are modeling approaches to deal with those varying sampling rates and uncertainties. But first, it's based on what is the question and what data are needed to answer that question. And then if we do need to harmonize data, we do so using best approaches. Thank you.
All right, next one is for Patrick. Here we go. How can those interested get involved in the bird and bat subcommittee that you mentioned?
I guess sign up at the RWSC website is what I would say. So those calls are monthly, I think like the fourth Tuesday of every month or something like that. And yeah, we report on our progress every month during those meetings. So yeah, that's where you can voice your feedback on any presentations or get more involved and actually join the tracking working group if you're interested.
You can also just contact Pam or myself to get on the list, or I guess Pam, because I'll just forward your email to Pam.
I promise I'll respond. All right, here's one for me. Any tips on integration of MODIS stations offshore on turbines based on past experience? What are the biggest challenges to offshore integration? So thanks to NYSERDA, we had a funded project that released protocols in 2022 for offshore MODIS stations on turbines and buoys. At the time, those were informed by kind of the best available information that we had. The intention was for those to be living documents. We haven't updated them quite just yet, but we've learned a bit more in the past kind of couple of years, I guess, since we released those protocols. So those are probably ready for an update. There's not anything majorly different from what we're doing now relative to what is in the protocols, but in terms of challenges, definitely the connectivity piece. So trying to get data from offshore stations onshore is really challenging logistically and can be really expensive with satellite data. So that's one of the reasons why we launched this project with NOAA NESDIS to try to get stations connected through their GOES satellite system, which will basically zero out the cost for the data transfer because it's really low bandwidth, so it's compatible with GOES. So we're working on that now and hoping to solve that big challenge through their technology. So super excited about that. And stay tuned for updates to the protocols, but they're pretty much up to date currently as available on the MODIS website. And you can always reach out to with specific questions. Here is another one for Patrick. Is there an approach to species prioritization that is not site-specific?
Yeah, I mean, I think this process could just be run, without the exposure component. That's one way to do it without being site-specific. Yeah. I mean, I think you could. There are other ways to kind of filter the list too. Yeah, I could see doing it kind of like a regional level, removing, just doing northeast or southeast, that kind of thing. I think it's kind of as simple as that, really.
All right, so here's one for Autumn-Lynn. Can you describe the mechanism for determining when projects are used and how the tag owners are notified?
Yeah, thank you. So far, I'd say right about now, we're starting to get at a point where we're maxing out our quantitative ecologists and conservation specialist time. So far, we've been able to support any conservation request that has come to us, but we're starting to get more unsolicited requests from the website and some bigger requests. And we have the advisory group to help us with that purpose, so to really help strategize on what support may have the biggest impact on reducing shorebird decline. So the advisory group serves as a resource for us if we really have to prioritize our time and pick and choose projects. And then beyond that, I'm always thinking our first round of funding is 3 years. So if we are maxing out our staff and there is this demand and need for support, then we need to hire more people. And so bringing in more funding for that is a goal. So I think we really don't want to turn away any request. And there are some projects where if the analytical expertise is in-house by the practitioner, then maybe we can find a way where data can just be transferred. And that actually happened with Canadian Wildlife Service. So they really didn't have time to pound the pavement to ask every individual contributor for permission. We had that already sorted out. we gave them an initial survey of maps that they could use to think about how they were going to do their analyses. And then they said, we'd like to run these Brownian bridge models with the data. So in that case, we went back to the contributors for like a phase 2. So some of our projects are phase 1. We just want to show the practitioner where the data are, and then they can figure out how they can use them. And so round 2 in this case was, can we give them a subset of the data just through their region of interest? They can run their models on it. And so that relieves some of the burden of our quantitative ecologists. So it just depends on these conversations with the practitioner. But in either case, I think about 60% of contributors pre-approve their data to be used in any conservation or management purpose. But we still send a notification before we share the data. Because sometimes you just never know. Like, depending on the use, they might have pre-approved it when they wrote the data sharing agreement, but maybe they have a student that has started that has an overlapping project with something that's been requested. So they might not be as comfortable when we actually send the request. So we just want to keep everyone in the loop. But we have this standard form that we send to either ask for permission or to just notify them of the use. So that's how we keep in touch.
All right. Next question is, I think, probably one for me. Any thought to adding GPS base stations offshore? So those base stations are detecting animals like terns that have GPS tags that are collecting and storing GPS data and then offloading them using, bless you, using UHF to base stations. So the trick with those base stations is that the bird and the station have to be in the same place at the same time for long enough for the tag will attempt to offload every hour according to how we have them programmed, but it's flexible and it's trade-off with battery. So the bird and the base station have to be both trying to do a little handshake before they start transferring data, and that requires the bird to be in close range. So using the kind of off-the-shelf model of base station, it's about 500 meters optimistically. So it's best to put these things at staging sites or nesting colonies where birds are hanging out for a long time. I think maybe at some point we'll be able to get flybys, but it's not quite optimized yet. So those are thankfully best off on land where they're much easier to set up and manage. We did have a question that I think, oh, thank you, could be directed towards Nate. I'm trying to get some bats in the mix here. It's kind of a chewy question, and we only have 3 minutes, but it's around like characterizing regular, predictable population behavior in the landscape and in the oceanscape with pressures like white nose that are known to change behavior and survivorship.
That is chewy. I mean, so specifically with white nose syndrome, that's going to affect a subset of the species that I put on the board, and once the bats have left hibernation, about 2 weeks, 3 weeks, maybe a month afterward, they are all healed up and about as normal as they're going to get. That's in a situation where a bat has survived white nose syndrome in the wintertime and is now flying around in the summer. So by the fall, white nose syndrome effects should not be a consideration. If you're talking about bat activity in the wintertime, if it's a white nose bat, it's very likely dead or going to die. In the springtime, you do have this interesting window of time following right after they emerge to the point at which they are healed up from white nose syndrome. It's about a 2 to 3 week window. And in there, you do have very measurable impacts of healing that the bats are trying to grow pups at the same time that they're trying to put on weight, at the same time that they're dealing with temperature drops and wild weather. But then their immune system is also really amplified because they're fighting off infection and growing their wing tissue back. So there are energetic signals in that where bats are using less torpor and are having to forage more often to help build their fat stores back up. So in the context of how do we characterize those behaviors when you have these kinds of impacts, I think it's just a matter of making sure that we have really strong data as to when those, like temporally, when do those effects happen. With HPAI, I don't have an answer. I don't know. But with white nose syndrome, you do have a pretty narrow window that these bats are going to get hit by it. When, of course, you're talking about the migratory tree bats, white nose syndrome isn't a concern. So if you can isolate that temporal frame that you're looking at, then you can at least characterize that. But it would be exceedingly hard.
Thanks, Nate. Sorry for the curveball right
That's okay.
Right
there was a
outside.
question that had my name on it, and I was like,
really?
oh, that one doesn't seem that hard.
Oh,
And
I missed that one. Well, you can ask Nate after for the easy question, because we're right at 5 and it's been a long day, so I want to make sure everybody gets out on time. But thank you so much for sticking it out through the end, and feel free to reach out. Yeah, and we're going right into the second night of the poster session. It's shorter tonight from 5 to 6:45. Pretty much same setup as yesterday. There isn't food. We left you time to get dinner after. And both bartenders will be out in the tent. There won't be a bar upstairs this time.